polymer batteries connected in parallel. The 6 thrusters on the robot receive their power through a bus relay that gives off 25 volts. And other components such as the computer or the fiber optic transceiver, which receive either 12 volts or 5 volts, get their power from an ATX power converter. What's really great about this power converter is that regardless of voltage spikes or voltage drops, it'll continuously give off the power. The computer we're using is a dual quad-core Intel Sandy Bridge processor on a mini ITX board donated by Intel. We're using Guppy Firewire cameras, which we chose because they're lightweight and compact, great for these kinds of projects. We're also using Computor motorized lenses to control zoom, iris, and focus through software rather than by hand. That way, every time we need to adjust, we don't have to open the hole and risk possible leaking. We're also using fidget devices. We like fidgets a lot because they're really easy to use. They simply connect to a computer via USB cable. We use fidgets for our motor speed controllers, our compass, and an interface kit. The term is plug and play, so they're great. And we have a fiber optic transceiver because we felt that it was critical to have the ability to remotely control the robot. And finally, we make sure that all connections to the hull are waterproof using subcon and CCON connectors.
So all our AUV software is written using Visual Studio C#. We chose C# as the main programming language because it is very similar to Java, and since Java is an AP class taught in our school, it's more easier to get students into the programming team, and so therefore we have more programmers that way. Also, thanks to the help of the Cornell University AUV team, we're also able to do a lot of good vision tracking using the AForge.net framework. AForge includes a lot of different vision methods such as circle tracking, block detection, color filtering, and much, much more. Another thing that's special about our code is our command interface. So what this command interface allows us to do is see visual displays of everything that is going on the robot and all its sensor readings. It also allows us to interact with the robot when it's in the water so that we can do testing, we can do adjustments anytime, in real time. We also included in the command interface the mission planner. So the mission planner is basically the system that the robot follows to know what it does, what it has to do, and how it does it. In that mission planner as well, we can also change any of the variables before the mission. So let's say we have to do red buoy, green buoy, then we can actually change that real time right before the mission and then just play it and then wait for the mission switch to go on and then it'll run the code.
While running our electronic system, we ran into a few issues. So from those experiences, we learned about voltage suppression and how to better splice our USB cables into subcon connectors. And while trying to design our AUV to be very compact and dense, we realized that there was an overheating issue. So to correct that problem, we installed miniature fans throughout the ladder structure, and we lowered the minimum CPU processing power. And while trying to make it really dense, there was also a problem where it made the AUV very negatively buoyant. So to correct that problem as well, we had to install flotation devices, and next year we are planning on making the AUV hull larger so we can add more positive buoyancy, making it neutral.
And so some of the things we learned from RoboSub this past week actually is first thing, putting red filter on top of your cameras. We actually got this idea from the Iceland team, Reykjavik University. And so what they told us is that as you go deeper in the water, the red and the red light in the image is the first thing to go away very fast. And so we're putting the red filter on. It pretty much reduces all light except the red light. What that does is basically make the red light show more. And so therefore you have a more realistic image of what is actually in there rather than a green blurred out image of what you would usually see. Another thing we learned from the Embry Riddle team is that you can buy a Fidget SBC unit kit. What that allows us to do is integrate hydrophones into our robot more easily using fidgets. And since we're mostly fidget based, it's really easy to integrate to that. And therefore we can, hydrophone and sound triangulation might be more easier than we thought it would be.
So this concludes our presentation. Thank you, judges, for spending your time here and listening to us. We wanted to know if you guys have any questions.
So So you have a lot of good lessons learned from a lot of the other teams. So you guys spend a lot of the time here going around and quizzing people. Do you talk to people?
Yeah,
during?
it's kind of like a requirement. So our team has to get a notebook and go around and just see all the other robots and ask questions. And they've been extremely friendly, like the latches, the programming help, and the lessons. They've been a lot of help.
Two of the teams you mentioned, you guys called.
Yeah,
Sent emails.
yeah. And they're really friendly. They'll reply you really quick.
They seem to appreciate the calls.
And we enjoy them.
How much time do you get in tanks to test your vehicle?
Well, this year we focused on getting the robot done, so we could program it for the next 3 years. So we had like approximately a month of water programming. So it's not much, but next year we kind of focusing on just programming, trying to get most of it down.
So this year we actually, because we knew that we only had a month, we decided to look at the scores from last year and decide which tasks we need to focus on in order to basically make it into the finals. So that's pretty much our goal this year. So far we've been able to hit 2 buoys, so as long as the teams haven't improved too much, we should have a solid chance.
That was a smart thing to do. Not too many teams do that. You know, one of the other interactions we've seen over the years that you may think about is with the other teams is that, you know, a few years from now you'll be on some of those other teams.
Yeah.
Okay. That's happened before with the high school teams. You know, they come back and suddenly they're on the Cornell team or wherever. So be sure you apply to those places.
We don't plan to.
Yeah, right.
So which tasks are you not going to do? You're going to do everything but grapes, I guess, and what else?
Well, we're planning to dead wrecking right after the 2 buoys we hit. And so basically we plan to do both the obstacle courses and the bins. So we're pretty much giving up the torpedoes, we're giving up fine-tuning of the bins and the grapes. And we're also taking a chance and just picking one octagon to ride above it. That way we at least get bonus points, so even if it's not the right octagon, we still get a time bonus for doing the mission really quick.
So how do you guys go about recruiting in young groups?
Well, in our team, there's not an exact. Well, to get here, there is a requirement that we all have to go through. We all have to make sure we fundraise and everything. And our team goes from freshmen to seniors. So whoever wants to join, I mean, they can, and they work their way up to come and get here. Basically.
How many hours a week do you all put in to this?
Well, during build season, usually Monday through Saturday, around 8 hours a day, depending on, like on Saturdays. We have school, so right after school at 3 p.m. when we get out, we work till like 7 to try to get the robot done. And then we come in on Saturdays and Sundays sometimes.
Average 3 hours a day after school.
So we
How big is the school?
2,000 plus kids,
2,000.
and there's about 4 or 5 team members we left off.
It seems to me, as big as the group is today, it was bigger last year. No.
Same number.
Same
14.
number? Okay. I recognize a lot of faces. So can you tell us a little bit about how many will be coming back next year or not, and where people are in 4 years and out of high school?
So
I can answer that a little bit.
I'm sorry.
Once the kids graduate high school, the second they graduate, we are no longer able to transport them. So since they worked on the project all year, we thought it'd be unfair for them not to come. So their senior year have to provide their own transportation to get here, and I'm not responsible for it. But I don't feel it's fair to not let them participate since they worked on it. So it's their last hurrah. So typically they could be here freshman, sophomore, junior, senior year, and then after that, hopefully they're on one of these other teams or some other program, any place, as long as it's technology based. That's what we're trying to get. And it's exactly what the gentleman back there said. We saw in the standard land-based robotics competitions we were doing in FIRST Robotics that there's a lot of competition out there that are all doing the same thing with only 15 seconds autonomous, and of those 90% of the teams can't program autonomous. And then we looked at data like during 9/11, there's maybe 20 UAVs or autonomous vehicles, and we military's arsenal, now there's over 20,000. So if we're going to spend time learning how to do something, we can do what everyone else is doing, which we think is wrong, and not quite accurate enough, or look at what is really the field that's expanding, and that's autonomy. So that's why we decided to. We'll still do the teleop robots because we have probably another 10 kids that are involved in that. But for this one, the level of students one notch higher because they worked all summer. We haven't had a day off just to get here. And the hope is that the skills that they learn here are going to translate directly to a college team or to the workforce. The person taking photographs back there is a sophomore in college, and he went through our robotics program. He is a sophomore in college, and he works for Intel with their robotics program, their outreach to do quadcopters and bipedal robots. He's making $50,000 a year. He doesn't even have a degree. I've been working for 25 years, and I made $58,000. So between all the information we dispersed, they can see this is the future. This is what they need to do. And that the scenes you see in Star Wars where the robots are actually fighting the war are not as far as you think it is away from now.
So how many of the seniors should graduate this year? Who's graduating?
Next year.
And we have a couple students, one's coming this Friday, and another one's already here right now that graduated this year. They're here, and now they're on a mentorship kind of thing too. So it's really cool.
I was impressed with the webpage. Do you have a responsibility for the webpage?
She's not currently in the room, but she's here.
She's now on the line.
Liz is the one that graduated the senior. She drove actually in with John, and then so she didn't come into the presentation.
Yeah, if you guys want to come up, you guys can check out our robot or anything they see that looks interesting.
I'm fascinated by your the aluminum thing or whatever this. Yeah. We have a big rust problem in there.
Yeah, a new anodization process. Yeah.
Talking on the billions of dollars.
Yeah, so this new process is